The following projects are winners from the last City of Zion developer competition. These projects and many other projects highlighted today are truly a token to the versatility of the Neo ecosystem and the creativity of the developer community. So the next 4 are all demos that were recently built into the Neo ecosystem. It's gonna be really exciting to see what they've been working on. And then after that, we'll do a little award ceremony where you'll get to see, more fun stuff. So our first presenters are Joe Stewart and Shane Mann. Joe is the CEO of Splice, a blockchain development consultancy focused on the Neo platform. He's a member of the City of Zion developer community and is a founder of Subproto Hackerspace in Myrtle Beach, South Carolina, and is a co-creator of Neo Smart IoT, Neolink, and Hash Puppies. Shane is the CTO of Splice and is also a member of the City of Zion developer community. His background is in the field of programming, project management, information security, and has been instrumental in the development of Neo Smart IoT, as well as Neolink and Hash Puppies. So give it up to the team.
All right, thanks everybody. Hello. Yeah, this is our DApp competition entry. Some people call it DApp. I've been calling it DApp. I was finding it roll
Yeah, I
off
was
the
just
tongue.
thinking that over earlier.
Yeah.
I kind of like that.
But yeah, this is what we did. So again, if you've been on the Discord or before that, the Slack, you might have seen us around. I came in as Hal9000. On GitHub, I can't get Hal9000, obviously it's taken, but Hal 0x2328, not Halo. So it's just Hal9000 in hex. And then Shane is Fetter, everywhere he goes as well. And yeah, we started this company back in May. We weren't actually into the Neo blockchain at that time. This whole thing was born out of the hacker space that I founded 4 years ago called Subproto. And we don't live in an area that has a lot of technical community. We live in Myrtle Beach, South Carolina, and it's mainly a tourist town. So there's not a lot of opportunities for people like us to socialize or work together with other people with like-minded interests. So I started the hackerspace and just invited everybody in. I had actually met Shane years ago. We'd worked at a company together, and he was still in the area. So when I found out, hey, come on in, Shane. We'll work on some stuff together. And we decided we like doing electronics. We like doing computers, and it was just natural for us to start working together. So when we started getting into the Neo platform, found out about that, we saw the DApp competition, and we said, hey, we should do something for that. So the question was, well, what do we do? There's so many possibilities. We didn't really know what everybody else was going to work on. So we just went back to our roots, and at the hackerspace, we like to play with electronics all day long, and had built a few Internet of Things devices. We built our own thermostat. It was Wi-Fi enabled, and so we thought that might be a good thing to do, to take IoT devices and put them on the blockchain. So that is what our DApp entry actually is. Neo Smart IoT was designed to allow you to control any real-world device using a smart contract on Neo. And the advantage of doing that is now you can take some amount of currency, in our case gas. You could have micropayments, because that's a great thing about the Neo platform with feeless transactions, is you actually can do micropayments that really aren't a possibility on other blockchains. Or you could just do it for free. It depends on your use case and how you write your smart contract, but it was really appealing to us. So we wanted to make a platform that was generic enough where you could use it to control any number of devices. If you wanted to make it into a vending machine, something that would open a lock, or play a song on a jukebox, or maybe you could even advertise. You'd have an outdoor billboard that had an electronic sign, and maybe you could use the blockchain smart contract to send the next advertisement to it just by paying for it. And again, all without having any middleman to take a cut of the profits. So that was our idea, and this is how we built it. Basically, at the core of everything here, we've got our smart contract on the blockchain. On one side, you got the user side, you've got the web interface. You've got the wallet that they have to have open to invoke the contract and send the funds. And then on the back end, you've got to have code that can know what's happening in the smart contract and can react, and then the final end device, which actually performs the action for you. So we'll break down all of the components that we wrote to do this. We're going to start with the web front end, which is actually the part that Shane wrote, so he can talk a little bit about that.
Yeah, the web front end is a Sales.js-based application to basically provide a payment interface. So we try to abstract it away from any particular device. You can pass in numbers, hex values, strings. Eventually, it'd be nice to be able to set dynamic payments. But yeah, that's what gives us the interface to the blockchain through another component.
Right, and we made it fairly generic so that people could look at it and figure out how to extend it to all kinds of different devices. So it's got a little bit of flexibility there. It's not terribly pretty. We're not designers, but we did the best we could. So next is actually a component that we didn't really enter as part of the DApp, but we felt that it was a necessary piece of the ecosystem. You've got Ethereum has MetaMask, where you can have any DApp can just use this Chrome extension to perform the wallet functions and the invocations. It's like we need something like that for Neo, and there wasn't something already, so we're like, well, let's write that. We'll just release that and make that a City of Zion project, and kind of let it exist on its own. But we'll also use it in our DApp. And,
yeah.
Shane was also instrumental in writing that. Again, being the JavaScript Node.js expert that he is. So you can talk a little bit about how you made it, and then where the development has gone now.
Yeah, I started out with just a basic browser extension template, and from there started adding features. But I do have to say that the Neo community cause has been incredible. They picked it up in the Neo League channel, and we've just been adding feature after feature. We've worked in React. I was just looking at some stuff today about message passing improvement, excuse me, between the back end and the pop-up piece. It's been really incredible.
Yeah, so that is out there. We're working on getting it to a beta phase where we can actually put something in the Chrome store and have people able to just automatically add it. Right now, if you want to play around with it, you can. You can just go to the GitHub and you can go into developer mode and you can build it and you can install it and play with it. And work with it on the testnet, obviously, for now. But yeah, we're hoping this turns into a reliable platform for other dApps to use over time. So the next piece, now we're moving towards the back end and how things interact with the smart contract. So what we had to do was make a node, basically, for the Neo network that is hooked in, can monitor notification events coming from the smart contract as the blocks are processed, and then do something with them. So the way that we tied these two things together was using a protocol called MQTT. So MQTT is just a pub sub, basically. It's basically a chat channel for devices. So it's just simple message passing. You subscribe to a channel, and you're just connected, and you listen, and then every once in a while, a message will come across. It'll be broadcast to everything that's subscribed. So it's a very simple, straightforward protocol. And the great thing about it was that there were already libraries written for the IoT platform that we were using, and also libraries written for Python. So it was kind of a no-brainer. We were able to take code that had been written by Tom for NeoPython and basically adapt that to talk to the MQTT server very easily. All the libraries are ready. NeoPython is a great foundation for any kind of automation you want to do on the blockchain. That's really a great place to go to, because a lot of code has been written. A lot of features are available in NeoPython that really don't exist in the other wallets right now, too. So it's definitely worth looking into. So hopefully everybody that made it last night to Chris's workshop already has NeoPython set up and running and is taking advantage of this. So the script we have, and it's available, that we released in the GitHub, is the neopubsub.py. You can take a look at it and see how that works. if you want to take this and adapt this for your own purposes. And then we have the smart contract, obviously. And that, again, is something that, that I wrote in Python because, Tom's great Python compiler also fantastically allows you to quickly write code, debug it, really quickly deploy it, test it, and iterate over the cycle much faster than having to go through the old GUI interface and compilation with the .NET toolset. So it's really great. The smart contract that we wrote for this is called the El Caro contract, and I named it that because it's kind of the opposite of an Oracle contract. In an Oracle contract, you want to know something in your smart contract about something that's happening in the real world. In this case, what we want to do is we want to tell something in the real world that something happened in the smart contract. So it's a very simple, straightforward, easy to read contract, I think, where you just got a piece of code that looks for the incoming payments to make sure that they match what is being requested for that particular item. And if the price is met, then it'll send out a notification message that can be watched for by the Neo pub sub, where it can publish to the MQTT code. And so you just have a few checks in there to make sure that everything is going correctly. And then you have some administrative code where you can set what types of values you're looking for whatever device. You can name them, and then you can add new ones and delete things. And basically just maintain this system of tracking for all these different IoT devices you might want to hook up.
Hey, Joe. I think your badge froze.
My badge is frozen?
Looks like it.
Oh, cool.
It's not blinking.
Neat. Yours is blinking.
Yes.
Nice. Giving away all our secrets, man. So the IoT device firmware, that's pretty straightforward. We went with an Arduino-based platform, so it's very easy to read and write. It uses a language called wiring, which is a lot like C. And again, there were libraries already available to talk to the MQTT service, so it was very straightforward to actually write this. So we're supporting, right now for the smart contract, the example code in the GitHub repository is written for a Node MCU. They're these neat little Wi-Fi enabled devices. You can get these for about $3.50, and they're really nice. They again support the Arduino ecosystem as far as programming, have the built-in Wi-Fi capability. It's very straightforward to set them up, update them even over Wi-Fi if you want to. But
the ESP32 also supports encryption, which could be nice.
Yeah, it's a great platform, but you're not limited to just that platform. You can also use any kind of Arduino platform that supports some sort of network connectivity, whether it's Wi-Fi or if it has an Ethernet shield or whatever you want to use. You're not limited to that. As long as you can incorporate that MQTT library, you're good to go. So the badges that we have here are actually running our Neo Smart IoT firmware. And so we are actually connected to our smart contract on the blockchain. Actually, I guess
you may want to reset yours because I was getting a signal that
you're connected and I'm not connected.
Yeah, just hit your reset button there.
All right. So it goes red when it first comes up. Blue means that it's got Wi-Fi, and then green means it's actually connected then to the pub sub queue. So is that quick? It was able to reconnect and test it. And so what happens is if someone invokes that contract, then they can change the color of the badge. So we thought for our demonstration, it's kind of a little bit onerous to try to expect everybody to be able to do this while we're on stage here. So we decided, well, we have a second presentation later today where we're talking about our Hash Puppies project. So we thought we would carry over the demonstrations so that we would show you how to invoke the contract and change the badge color. And then if you're one of the addresses that we see an invocation come from during our talk, if you're up here changing our badge colors while we're on stage, then we'll give you one of our redeemable Hash Puppy tokens. So when our game comes out, you'll be able to get one. And we were going to give away the first 10 addresses on RHT, but now we've seen the huge turnout here. We saw what Ontology is giving away, so I feel a little bit embarrassed about just 10. So let's just say 100 100 RHT, first 100 addresses to invoke the contract while we're on stage during our Hash Puppies presentation, and we'll hand those out later. So that will be our actual demo. So this is the information you will actually need in order to invoke the smart contract. There's 2 ways you can do it. You can use that demo code that we showed you, the web front end, and you can go to the GitHub and you can actually learn how to use that through the browser. Or if you went to the NeoPython workshop last night, you have most of what you need already set up probably. But instead of using your private network, you need to switch your NeoPython over to the Neo testnet, because that's where our smart contract lives. And if you go ahead and sync up your blocks up to the current limit, and you put yourself a little bit of gas into your wallet, maybe you can ask somebody in the room for some testnet gas if you don't have any, then you can change our badge color. So what you have to do is invoke the contract with that hash, and then you're going to use the put value in an array. If you're going to change my badge color, it's HAL is the first argument to that array. If you're going to change Shane's badge, it'll be FET. And then you just pick an RGB color code, and you see somebody just invoked my contract. So yeah, you just attach 1 gas to that transaction with an RGB color code, and then the badges will change. So we'll do that during our talk, and then we'll go back and we'll see all of the addresses that did that, and we'll reward them. So we're just doing that as a way of saying thanks for making this such a great community. We want to give you guys just a little bit of reference material here to go back if you want to have fun with us during this next session, and yeah, that's basically it. I think we have maybe a little bit of time for some questions if anybody has any.
Over here.
Quick question. So right now you're looking at the IoT for payment services, but are you also, can your smart contract handle a message back, for example, vending machine is empty, or there's a failure? So is it a two-way communication, or is that something you're thinking of in the future?
That is something you wouldn't have to go through the smart contract to do that. You could do that just by passing that message into the MQTT server, and then you could have another subscriber that would listen to handle that status. So you could use the same communication channel, but it doesn't necessarily need to go through the smart contract. Over here. Yeah.
That's a good question.
Yeah. So obviously, IOTA is kind of built to exist on those devices, and they're supposed to make this huge magical mesh network where transactions are magically processed without the need of centralized or somewhat decentralized nodes. It's supposed to be some crazy scheme that's going to, revolutionize IoT. We're talking about a much more limited thing here. We're not putting any actual blockchain code on our devices at all. They're very simple, and they should be. They shouldn't have to have a lot of complex code on them. They should just do one thing and do it really well. So we went the route of simplification. Let the blockchain do the heavy lifting. We think that Neo can support it. Based on the transactions per second, it should be no sweat for you run thousands of these devices and control them at any time, and have it happen within at least a minute from the time that you broadcast the transaction. It goes to consensus and gets rebroadcast back. Your node handles it, publishes it, and then it changes its state.
We were considering doing some battle testing to see how many transactions we could do, maybe what Neo could really support. I know MIOTA is, they're looking forward to trillions of transactions a day potentially. So that's a lot to keep up with.
So I think we might be at time now if we don't have any more questions. Cool. All right, thanks, guys.
Thanks, guys.